I think we can start. Okay, welcome everybody. Welcome everybody, people in the room, students, and colleagues, as well as people attending from home, participants attending from remote. Welcome to another seminar organized by the Abstraction Group and the Abstraction Research Project, sponsored by an ERC grant called Abstraction. Our speaker today is Kristina Kobrock, and let me introduce briefly Kristina. Kristina is a third-year PhD student in the Computational Cognition Research Training Group at Osnabrück University in Germany. She obtained her undergrad degree, so her laurea triennale, in cultural studies and business psychology at Leuphana University in Lüneburg. A lot of German words here. And then her Master of Science in Cognitive Science at Osnabrück University. And she is now in her third year of her PhD, which is a fantastic project, I must say. When I read about her project, I was stunned by the depth and the interesting aspects that she's addressing. She's supervised by Nicole Gotzner, who is an expert in psycho-neurolinguistics, and Elia Bruni, expert in computational linguistics. And basically, the main research question in her PhD project is how does language support higher level cognition? So this is very much related to the topics investigated by abstraction. Her hypothesis is that abstract concepts can only be formed with the help of language. So language is crucial and is central for the construction and development of abstract concepts. I think, and I completely agree with Kristina on this topic. So when we got in contact and she outlined her project, I was very surprised and very happy to find a way to collaborate with her and hear more about her project. Kristina is in her PhD and she has already published an article in collaboration with a very established scholar, Timo Rutger, and a couple of articles in the conference proceedings, like major conferences, CogSci and LREC calling. And so we are very, very happy and curious today to hear what does she have to tell us about investigating linguistic strategies for abstraction. So Kristina, the floor is yours, and thank you again for being here today.
Yeah, thank you for the introduction, and thank you for having me. I'm very happy to tell you a bit more about my project today, and I hope we can have a fruitful discussion in the end. And I'm very curious to hear your thoughts about it as well. So the title of my talk is Investigating Linguistic Strategies for Abstraction. So this is what I will focus on today, and I'm going to show you evidence from 3 studies I've recently conducted, where I believe we gained some insights about the language-related strategies speakers use to communicate abstraction in various ways. So first, the first project, so I'm giving you kind of an overview now about what comes, and then we'll go through the 3 projects. So the first one investigates abstraction through the lens of referring expressions. So here the idea is that when we want to communicate a concept, so for example, put emission in the picture, then we typically do this by use of referring expressions. And these can range from the subordinate to the superordinate level, basically. And by investigating these, we can gain insights into the kind of concept that the speaker wanted to communicate. And here I conducted a reference game experiment with human participants, which is different from the other 2. That's why I'm pointing that out. So the other 2 are computational modeling projects. So here we're dealing with artificial neural network-based agents, which learn to communicate with each other and develop a language by solving a communicative task. So it's a model of language evolution, where we started with nothing but the capacity to communicate, and through interaction, these agents develop a lexicon, a symbol meaning map. So here I want to look at generalization abilities. So when having established a certain lexicon, how well do these agents generalize to concepts at novel levels of abstraction? And in the third one, I want to look at pragmatics. So how does pragmatic reasoning, context, but also reasoning about the interlocutor's intentions help in dealing with language at like communicating abstraction in sense. So this is just the overview, and I hope everything gets much clearer once I get into the details. So first, the abstraction equivalence of referring expressions. And here I want to look at specifically superordinate referring expressions. So coming back to this image, we can use a very specific term, like for example, dimension to describe it. We can also use dog, or we can use superordinate referring expression, so to say animal. And we can say that we use subordinate referring expressions to communicate the specific and complete concepts, and the superordinate to communicate the generic complete. And now we know that at least two factors play a crucial role when speakers choose which referring expression they want to employ. One is the basic level effect. So speakers would typically say dog when just being asked to refer to this. And this is due to the basic level effect. Basic level terms are usually very short, very easily accessible, and they are also acquired before the sub or superordinate terms. So there's something that is special about them, and we tend to produce them more often because of that. The second factor that influences referring expression choice here is the context. So here we can look at in which context do we refer to things, and if the dimension is presented in a context where also, for example, now a dog is present, then we probably not say dog anymore, but say dimension to refer to this dimension in the picture. So these two things interact in such tasks, and the goal of the study was to investigate both the basic level effect and the effect of context in an interactive task. So looking at the production and at the comprehension of referring expressions. We based this on some previous work, which is a similar setup, and I'm going to walk you through the three most important results. So first of all, we can see here from their data that basic level terms are produced very frequently over all conditions. So this is in line with the basic level effect. It doesn't matter what you would need to communicate, speakers tend to produce these basic level expressions a lot. Secondly, subordinate terms are produced most frequently in a context where we have a destructor from the same basic level category. So another type of dog in this example. So in a context where you need to use a more specific term, basically to discriminate the target from the destructor. So also this makes sense, licensed by the context effects. And thirdly, what is very interesting is that superordinate referring expressions are not really produced overall. So even in such a context that you can see there, where we have just one animal and the other objects are actually inanimate objects, people wouldn't say animal to refer to the dog. They would say dog. And so the goal of our study was to look at and specifically elicit also the production of the superordinate terms. Yeah, that's what I just said. We wanted to elicit the production of the superordinate terms. And we do this by extending the standard reference game setup from one target, like we had in these displays, to multiple targets. And you see also an example in a minute. This allows us to look at production and comprehension at the same time. And the research questions we want to answer with this are one related to the effect of the context. So do the speakers choose referring expressions at the appropriate level of reference and the basic level effect in both production. So this is how our study setup looks like. A reference game, I'm sorry, I told you before, but the reference game there, the idea is that we have a speaker and a listener, so we pair two participants in a web-based interface, and they then interact. So the task of the speaker is to communicate the concept, and then the task of the listener is to select all objects which are described. And this has been a study that I worked on with Charlotte Uhlemann and the PhD supervisor Nicole Gotzner, and published this in the Proxide proceedings this year. And yeah, so the main difference to a standard reference game is that we now have two targets that need to be described. And so we can have a manipulation that where we look at which targets can we form and which are the closest destructor objects. So we define conceptual context in the A panel as two types of dimensions, so the same subordinate category, and then the closest destructor would be another kind of dog. And so this is where we would expect we can use the dimension. Then we have the basic level conceptual context where we have two kinds of dogs. The closest destructor is an animal, so the same superordinate category. And then here we expect speakers to produce dog. And then in the fourth conceptual context, we have two animals. And the closest destructor is an animated structure. And this is where we hope to elicit the superordinate referring expressions. And this is also in line with what hypotheses we registered. So first of all, we expect speakers to tailor their utterances to the conceptual context, so to the combination of targets and destructors, and this would be in line with the Bayesian maximum context. So telling as much information as is necessary for the communicative purpose and not more. And secondly, we would expect a basic level effect of production. So speakers should be especially quick when referring to the basic level and saying something like dog. And thirdly, on the comprehension side, we weren't sure whether to expect a basic level effect, also like just due to the facilitation of the basic level, or alternatively, facilitation of superordinate terms, because in visual categorization studies, it has actually been found that people are quicker to decide whether an animal is in the picture rather than to decide whether a dog or a. So we were curious about that. The study we conducted online, as I said, with participants from prolific, English-speaking, and from the US. We had a final sample of 58 pairs we investigated, diverse genders and ages ranging from 18 to 30. And we investigated not only the animal category I've been talking about so much, but also 5 other categories to generalize our findings a bit more. The conceptual context was manipulated within subjects, so we had 18 trials. And we collected both the production, so what the speakers typed in to refer to the things, and the response times of both speakers. And here you can see the results of the production data. And yeah, we can, like I color-coded the appropriate mentions. So whenever a speaker used the subordinate and fine, the basic level word in the basic conceptual context, and superordinate in a coarse conceptual context, this is color-coded, and the inappropriate mentions are displayed in gray. And yeah, inappropriate doesn't mean that they said something completely off, but it usually means something that they said something like spotted dog or dog and parrot, so they were using another term that still led to communicate successfully with the text. But importantly, we elicited the production of superordinate referring expressions here. So our goal was met, and we can conclude from this that indeed superordinate referring expressions seem to become relevant when we're talking about multiple objects or like more generic. Then let's look at the response times next. So here we can see a very clear basic level effect on the production side. So speakers are indeed faster when they choose a referring expression at the basic level. so something like dog. And this is also when we control for the length of words. So dog is a shorter word than animal, and length is a predictor in this effect, but the effect doesn't vanish when we include length. But there still seems to be a facilitation of the basic level that doesn't have to do with length. And thirdly, for the listener response times and the effect in comprehension, well, we don't have an effect in comprehension, so we do not find a facilitation of any of the levels in the comprehension data. And so what we can conclude from this is, first of all, speakers tailor their choices to the context. Secondly, superordinate referring expressions become relevant when we deal with multiple objects or a generic class. And we reproduce the basic level effect only in the production, but not on the comprehension side. So this might mean that the speakers are willing to bear higher costs and also produce referring expressions at levels which are not as accessible as the basic level, because they know that the listeners will identify the target space in that. So for the sake of communicative success, basically. And so we run an exploratory additional model where we look at communicative success and at whether or not the appropriate versus inappropriate mentions increase communicative success. And so the baseline success rate is already quite high. So this when people say things like spotted dog or dog and parrot, but when speakers choose a referring expression on the appropriate level, it increases the communicative success, so the probability of listeners selecting the correct targets by about 14%. So this might mean that, speakers produce referring expressions for the sake of communicative success, for the sake of the communication. And so what we can conclude from this first study is that speakers can choose to strategically communicate the information at a level of abstraction that helps in communicative success. So that makes comprehension easy for the listeners. So let me take a little water. And let's then into the next study. So here I'm looking, as I told you before, I'm using computational model. So this is a bit different now, but you will also see that it's very related to what I've been showing you before. So here I want to look at linguistic strategies for generalization to concepts at normal levels of abstraction in an emerging or evolving language. You might ask, why do I use computational modeling? And I think that computational modeling has a lot of benefits. So first of all, it allows for manipulations that we cannot do in experiments with human participants. So thinking about language evolution, we cannot go back and see how language evolved, but the only thing that we can do is systematically manipulate and control inputs that we feed to a system and see what happens in that system. And this can help us to generate new hypotheses, also human behavior. And computational models are also great because they force us to specify underlying assumptions that we might have. So it allows for rigorous research. And in our specific case, we use language emergence models to look at which properties the language has when having evolved under certain. So what do you need from this model, which is supposed to model language evolution? So first of all, we want it to be interactive again. So communication happens in interaction. So we need at least two agents, a speaker agent and a listener agent, and they should be able to interact. Secondly, we want to sense how much information needs to be communicated or which kind of concept needs to be communicated. And the hypothesis here is that the more specific we choose to communicate its concept, the more information we also communicate with that. And you will see later how exactly I operationalize the concept in this model. Oh, here, exactly, you will see it. Okay, so the idea is we have a speaker and a listener, they interact, and then the data set is made of objects. And it's, I'm visualizing this as objects with different properties, so different shapes, different colors now. But in the real model, it's a symbolic data set. So it's, you can think of it as having different colors, different shapes, but they don't see pictures, they see vectors, which is sufficient for a modeling framework. And how I operationalize concepts is very similar to the first study. So I assume that a group of objects that need to be communicated together form a target concept. And so the speakers need to communicate this array of objects, so the whole target concept, which consists of multiple objects, to the listener, and the listener then needs to select all of the matching objects. Yeah, and this is modeling framework that we based on a previous study by Nguyen Goodman, and then we also published some work on this already this year in coding proceedings. And this joint work with 2 PhD supervisors, William Gotzner, and also postdoc Kristina Kobrock. And the research questions I want to focus on now are how well do the agents generalize from a level of abstraction to a novel level of abstraction, and which linguistic strategies do the agents use for this. And this is called zero-shot generalization. It's a technical term. It just means that the agents see different things during training, like the language evolve, than during testing. And so we can have 2 different conditions, 2 different experiment settings. One is one is the 2 specific conditions. So here the idea is that the agents are trained on more generic concepts. So things like blue objects or circles. And then the agents are tested on the most specific concepts. So blue circles. And then the other condition is the 2 generic condition, where agents are trained on more specific concepts, so blue circles, orange circles, and then in the testing they need to generalize to circles. And we can look at like first the performance, and then secondly also at how do the agents use language to make this reference to a novel level during the testing phase. So the performance looks quite good. We have quite high accuracies overall, which is quite nice because, as I said, it's a zero-shot generalization. So they haven't, and it's not only held out concepts, so they not only have not seen the concepts during training, but they haven't seen anything at this level of abstraction during training. So it's it's a very wide step, so to say. To jump to another level of abstraction here. But the agents do this quite well. And what is interesting is that they seem to be better able to do so in the 2 specific condition than in the 2 generic condition. And these are just the baseline training validation accuracies. So after training, they have a lexicon. They can refer to the concepts that I trained them on with very high accuracies. And then testing, we have smaller accuracies, but they still definitely are better, performing better than chance, and for the 2 specific, even very close to the. So let's look at the strategies that the agents use for doing this. And the question is, do the linguistic strategies then maybe differ if we see these performance differences? And so I'm going to compare the number of novel and reused messages in testing with what they reuse during testing with what they use during training, and compare the 2 different conditions. And then also a message concept ratio, so the number of novel messages in relation to the novel concepts that the agents encountered during testing. And yeah, don't be confused, this is just the number of different data sets I trained this on, because I wanted to have more like generalizable results. So I used data sets with different sizes. And a D3-4, for example, means that the objects the agents encountered had 3 properties which could each take 4 different values. So the data sets grow larger the more we get. Here, at least in terms of attribute size, actually the 316 and the 48 are the largest data set in terms of how many concepts we can create. But importantly, we see that for the two specific condition, we have basically a 50-50 split between reuse and knowledge rate. So here the agents seem to reuse a lot of the messages, but they also create many novel messages to create to the novel concepts, to refer to the novel concepts. Whereas in the true generic, we have more reused messages and less novel concepts. And one way to think about this might be that for the two specific, it's easier maybe to construct new messages. And for the two generic, we need to rely, or it's easier to rely more on the reused messages. The next metric I came up with is message concept ratio. So here we can see how many novel messages have been created for how many novel concepts, basically, because the concepts also differ a bit in terms of their number in these different data sets due to how the data sets exactly are created. And so a number of 1 here would mean that in each novel concept, the agents come up with a novel message. They never do so, so they seem to be quite efficient. But then they tend to do so more in the two specific. So again, more novel messages being created in the two specific case and less novel messages in the two generic case. So here there's also a lot of reuse of the messages. Okay, to conclude, from this study, we see that agents learn to generalize fairly well to novel levels of abstraction, and they generalize better when referring to the most, or when generalizing to the most specific than to the most generic concepts. And they seem to use different linguistic strategies. I'm also probably not done yet with the analysis. I think that can be done more, but what you can see now is that the agents produce many novel messages when they generalize to specific concepts. So maybe they do something, they make use more of compositionality, because what other strategy could they use and still have such a good performance, right? They need to somehow reuse messages, messages as symbols they had used before and kind of restructure them to create novel messages that can still be understood by themselves. When generalizing to generic concepts, agents probably have a more flexible strategy. They seem to reuse a lot. So maybe they are also reusing messages that have a more specific meaning, and now they are generalizing and still using these specific messages to refer to more generic concepts, which may lead to overspecification in some cases, but still seems to be an efficient strategy that works quite well in terms of performance. Okay, so here the main takeaway is that linguistic strategies seem to differ depending on whether agents generalize to more specific or to more generic concepts. Okay, and the third subproject I want to talk to you about is the role of pragmatics in all this. And pragmatics, and also some students here, so the pragmatics is the study of factors other than simply only word meanings in language. So anything that's not encoded in the semantics and the word meanings can be referred to as being pragmatic. So a very frequent case is the role of context in determining the sense of meaning of the word. So here I want to look at pragmatic linguistic strategies in abstraction. And again, we're dealing with the modeling setup, the same model, the same data set. But in order to investigate pragmatics, I also add some things to the model. Communication, we still have this interaction. We still know how much information is communicated, and we still deal with language emergence. And we also want to measure efficiency. I'm going to tell you later how exactly I'm going to operationalize efficiency. Yeah, but now we need a solution for implementing the context-based pragmatics and also recursive pragmatic reasoning. So these are the main types of pragmatics I'm looking at in this slide. So either agents can make use of the context, or they can even reason about the interlocutor's intentions. So how we are implementing this is we're still dealing with the same modeling framework, which allowed us, you've seen this already in the previous study, to look at language evolution on the evolution timescale, but also we could look at situational use. So this is what we did during the testing, just using the model and asking it how you refer to this now. And doing the pragmatic mechanisms, first of all, by integrating the communicative principle, cooperative principle by Grice. So all these setups are trained on communicative success. This is how we let them evolve language in the first place. And secondly, I want to have a notion of how does context help. So here I'm manipulating the context as well in which the targets occur. And the recursive pragmatic reasoning, so whether speakers can reason about how a listener can interpret the things they said, is implemented by using the rational speech act model. Okay, so when we communicate concepts, we also typically do this in a context. So it's not only panel A, how I've showed you that we can refer to the same thing using different expressions, but we also tend to use, and this also goes back to the first study, we also tend to use different expressions depending on the context in which it comes to. So here we can say melon, but there are other melons we need to say watermelon. So the information that needs to be communicated also depends on context, and it's typically more information required and also more specific referring expressions being used in defined contexts. So this is the kind of the idea that I'm implementing in the data sets, where I manipulate now also different levels of context, not only of the concept, but also basically how do the structures relate to the target concept. Are they very similar? Then it's a fine, yes, then it's a fine context. Or are they very far away from the target concept? Then it's more coarse. For the pragmatics, then we compare the three game scenarios. So we have the baseline model where speakers communicate concepts without being able to reason about context. So they simply don't see any context to prevent them from doing that. Then the second is speakers communicate concepts within a context. And the third is pragmatic reasoning. So here I'm using the rational speech act model to model pragmatic reasoning. And it's a dangerous looking formula, but it's quite easy actually. So the idea is simply to maximize the probability that the listener selects the targets. So we imagine that the speaker can know which targets the listener is likely to select, given certain utterances that the speaker chooses. So yeah, basically the speaker can go through the utterances that are candidates. So for example, circle and blue, and then they can think about how the listener will interpret this utterance and whether this will lead to the listener selecting the correct target objects. And then in the tradition of the RSA model, there's also typically a cost associated with messages. So typically it's a cost on the message length, which just makes the whole model a little more efficient because the messages tend to get shorter, or like shorter messages tend to be preferred. I'm going to skip the details actually. Just let me point out that we're using utterances that have been produced during the training, also for the RSA evaluation. And also that we take both targets and distractors into account for the calculation of the probability that the listener select the target. So our hypotheses for the 3 different game scenarios. The first was the baseline. So we have agents which don't have access to the context. And this is simply implemented by having a speaker which has access to targets but no context. And then the listener. This works as before. And our hypothesis for this scenario was that in order to be successful, speakers have to communicate all the relevant attributes. They need to communicate in a circle because they just don't know in which context the listeners will see these objects. Then the second one is context aware. So here the speaker actually has the actual context. And so it knows in which context the listener will see the objects. And they can rely on the context for that matter. So they could, for example, choose to utter less attributes than are relevant for the concept if the ambiguity can be removed from looking at the context as well. Thirdly, we look at the Rational Speech Act implementation of these agents. We have the context unaware again, but with this reasoning module. So the speakers are able to reason about what the listener would choose. And in order to evaluate these, we look at how efficient is the emerging language. So efficiency has been typically associated with shorter messages and smaller vocabularies by communicating the same amount of information. And this is also what is important for a rise in pragmatic sense. So a rise in pragmatic message should communicate as much information as is necessary and not more. So intuitively, when agents have to communicate more information, they should also send longer messages. There should be more information in the messages. And use information theoretic measures to analyze this relation between the concepts and the messages, how much information is in them. So you can think of what emerges as a lexicon between messages and concepts. And so the agents typically have developed a one-to-one mapping between messages and concepts. So this is what most of the lexicon would consist of. Messages that refer to exactly one concept and concepts which are only referred to by this single message. So there's like a one-to-one mapping between these two, and this can be formalized as the normalized mutual information between these two sets. We don't have to go into the mathematical details. It's just we can formalize whether there's one-to-one mapping between messages and concepts, or whether there's other relations like synonymy. So when two messages can refer to the same concept, or also polysemy, where we can use only one message to refer to multiple concepts. And we're interested also in these off cases where we don't have a one-to-one mapping, because this is often where we see efficient language. So human languages always contain synonymy and they always contain polysemy because it makes the lexicon shorter while you're still being able to communicate a lot of things. So for example, in polysemy, we have just one word bank for both the financial institution and the physical building. And the context in which the word occurs typically lets us know whether one or the other senses. Okay, so for a highly efficient language, we would actually predict that there's a lot of one-to-one mappings, but also polysemy, which needs context to disambiguate meanings, and also some synonymy. Okay, so here I'm plotting exactly these scores of the different context levels. So we have a comparison between the context unaware, where we expect that speakers cannot make use of the context, see the context, and the context aware, where the speakers can, in principle, make use of the context. And the zero context means that the context is very far away from the target. So this is the coarse context, and the higher the context number gets, the finer the context is. So this is when the context is very close to the targets. And what we can see here is that the normalized mutual information, so the one-to-one mappings between messages and concepts, is a very flat line over different contexts. Whereas for the context aware, we see that there is an increase or a drop, if you will, towards the coarse context, which means that there is probably more polysemy and more synonymy and less one-to-one mappings involved when these context-aware agents communicate in coarse contexts. So we took this as evidence that the languages that evolve here take context into account. And importantly, this is without incentivizing the agents to use the context. The only thing that we changed is that we give them the context system. So this is an emerging property of the system. So as an interim conclusion on this, on the topic of context-based mathematics, it's that context-aware agents use more effective messages, so messages that single out the target concept in fine contexts. And there's more polysemy in coarse contexts. So with this drop that we see in the context-aware and the coarse context, this can signal the language is a bit more efficient, and it relies on context because polysemy can only be disambiguated in context. We can also conclude that context-aware agents learn to communicate efficiently, they adapt to the context conditions, and the mere presence of the context drives its use in communication. So having trained this without further incentives. Okay, so next, what about the other pragmatic strategy? What about the RSA strategy, where speakers reason about what listeners, how listeners would interpret messages? Here we look at the same scores. The figure on the left looks a little bit different than the one before because I wanted to include the cost of the message lengths as well. But the general trend that there is no variability over the context conditions stays. Interestingly, now we see this also for the RSA. So there is also not really a trend like the one we've seen in the context-aware agents, but it seems to be again relatively constant through the different context conditions. But we have in general lower effectiveness scores. So maybe here we deal with more polysemous messages that require context for this information. To look a little bit more into whether or not this is an efficient language, we also look at message lengths, because as you know, the language is more efficient when it can encode the same information with shorter messages. So we have the context unaware baseline, where, just for different data sets, the message lengths are between 4 to 8 or 10 symbols. And when we look at the RSA, we see a drop of message length. So RSA trained agents seem to use shorter messages to encode the same information. And also there seems to be a trend that for more generic concepts that we can see on the left here, they use even shorter messages than for more specific concepts. And this also makes sense because for more specific concepts, the agents need to communicate more attributes of an object. So RSA seems to lead to higher efficiency in terms of message lengths, but we don't really know yet, like whether this is, or what are the strategies that they use to refer to specific or generic concepts, only that they use short messages to refer to the generic concepts. So now I'm plotting the same scores that we've also seen for the context of the different concepts. So here the further on the left, the more generic concept, and the further on the right, the more specific concept, so the more information is being encoded. And here we can get some insights into how the agents communicate more generic or more specific concepts, namely that for the generic concepts, they use some synonymous, but no polysemous messages. So, oopsie. Okay. So they might use things like small group circle to refer to circle. And for the specific concepts, they use fewer synonyms and more polysemous messages that require the context for the simplification. So yeah, this is like a trend that we can see in the RSA scores. So as a conclusion for the RSA model, we see that RSA agents adapt the messages to the concept level and not to the context level, as in the context-aware reason-aware case. Implementing RSA leads to the emergence of more efficient, so shorter messages. And RSA agents seem to have different strategies for encoding specific or generic concepts. Namely, they use more synonymous but polysemous messages in reference to generic concepts, and fewer synonyms but more polysemous messages in reference to more specific concepts. So to conclude this third part, the RSA agents especially, I guess more interesting in the others, they choose different strategies for communicating the more specific versus more generic concepts. And so as an overall conclusion, we had the part with the superordinates and the referring expression experiments, where we found that speakers are able to strategically adapt their choice of referring expression and communicate information at a level of abstraction that makes comprehension for the listener easy. Then we had the part where I showed that the linguistic strategies depend on whether agents, or the linguistic strategies for generalization specifically, depend on whether agents generalize to more specific or more generic concepts. And thirdly, I've shown that mathematics can help in the sense that it makes languages more efficient typically. And also we've seen that models where the speakers are able to reason about how listeners could interpret their messages develop different strategies for communicating specific generic concepts. So overall, it seems that linguistic strategies for abstraction depend on the communication objective. So at which level do we want to communicate? Are we incorporating? Do I want you to understand the information? And also, do I need to generalize and communicate something new that I haven't communicated before? And they also seem to differ for specific versus generic concepts. That's it. Thank you.
Thank you. Thank you very much. A very rich presentation, a lot of data and studies. So these are all parts of your PhD project, the 3 blocks.
Yeah.
Fantastic. Fantastic. So are there any questions or comments, curiosities? I would start then maybe, and I would ask you, of course, we have been working on abstraction, linguistic strategies for abstraction as well. And in one of our experiments, we collected letters of abstraction, so from very specific to very generic words with kids, with children. And it's in schools. And there, of course, the way kids generalize and the way adults generalize are quite different. So it made me think that, for instance, in the reference game, you may choose what level of abstraction to use, also depending on the type of person you have in front, right? So if I'm talking to students, I know that I can use, a level of specificity and technical jargon and so on. If I'm talking to a non-specialized person, I will use a different register, a different level of abstraction. So I was wondering whether in your studies you considered or you took into account the type of speakers and in a way some socio-demographic variation in type of speakers in your agents, for instance.
Yeah, that's a very good question. And I definitely think that
I mean, it opens to a
exactly.
completely new PhD.
So for the experiment, we did not consider different types of people, but it's, I guess, easy to do. We could just do it and collect some speakers with different background knowledge. And the important thing then, I guess, would also be to tell them that they have different background knowledge so that they can pragmatically adapt. And for the agents, well, they just develop a language from scratch. So it's they also have very limited linguistic experience, so to say, because they only develop this language in the diet where they are also tested. So they exactly know what the other agents knows or does not know, because this is all the linguistic experience they have. So it's a special case.
Thank you. Are there any comments or questions, maybe also from home? Let's see. Then Andrea. Yeah.
Comment on the question. First of all, thank you for this very dense presentation and very rich. And I would like to ask if we can go back to the experiment on generalization.
Sure. This takes a while.
Yeah, I know. There were a lot of
yeah, okay.
Yeah.
Where?
While you're going back, try to explain what I was thinking about. And you're saying that dealing with with the generalization on generic concepts, the agents were using less linguistic material to explain to the listener what they were referring to. While with specific, on the specific side, they were using a richer lexicon, let's say. I think this really reflects what happens with the human lexicon. Because when we look at what are the superordinate concepts, or to be more precise, superordinate the lexicon we use to refer to superordinate concepts, we have less elements than the one we use with more specific concepts. Because you can apply the same word, the same name, for example, to something that is really extremely generic or extremely specific from the generic point of view. But from the specific point of view, it's not possible to say. So it's really interesting that this also emerges with these agents that do not use the language as we are used to, but they generate their own code for communication. It's really, really interesting and enlightening. Thank you.
Thanks.
More a large question. So it's, I was thinking it's related all to your experiment, because you take a listener and a speaker, and there is this phenomenon called conceptual alignment. So I'm thinking how you think about so insert this, because this way it seems like a one direction to do something and you have to understand it. But you also thought about trying to see conceptual alignment and condition in the experiment or not, because I read this paper 2 years ago a colleague of mine, and they saw that with the people or in the joint interaction, also the choice of the particular concept, so more specific or more generic, depends on the conversation. So we were using a robot and the basic concept, people tend to reply with another basic concept. So if you answer the image of a fruit, and previously also about apple, and I will say banana, but before they say food, I will also answer. So I don't know if this will also be studied maybe with the agents and with combination.
Yeah, that's a good thought, actually. Yeah. I mean, I'm also, I've been thinking about doing this with the human participant experiments, actually. But yeah, I haven't thought about doing this with the agents yet. So a very nice suggestion. I guess you could do it and like use the testing phase for it from basically different levels, and then see whether this primes them, so to say, to use the same. Yeah.
It will be interesting to see also in the human experiment. So it is tend to see more like generic terms, we also have some kind of family effects. And if so, it's also depending, it's still a context effect, but it's more related to the entire conversation more than just
Yeah, yeah. And it also relates to common ground of the speaker and the listener and how much information they share when they can participate.
Okay. Are there any more comments, questions, curiosities?
Feedback, you can also tell me what you didn't understand.
If there are no more questions or comments, we are in perfect timing. So I would like to thank again Kristina and thank all the participants in the room and from home. The seminar has been recorded and we will put it, some reactions. We will put it on the Abstraction website, so it can be watched again. So thank you again and see you at the next Abstraction seminar. Bye.